So I see I have sine times cosine, cosine times sine. You should have realized it was sine. It was either addition or subtraction of sine.
Oh my god, I'm so stupid. I was frustrated.
And it's not cosine, because cosine would be cosine times cosine plus or minus sine times sine. That tells you it's cosine. So it's sine of an angle plus an angle. Well, sine of an angle plus an angle does equal what's above. It'd be sine alpha times cosine beta plus cosine alpha sine beta. Well, that matches what's above. So t is our alpha. 2t is our beta. So working this backwards, we're going to have sine of alpha, which is t, plus beta, which is 2t. So it should have came out with sine of 3t. Sine of 3t, so your answer should have been C. C is in coo. I got it right. Or crap.
I got it.
Coo. Like if you're too cool to add an L to it, like a coo. You know, you're cool, I got it right. Or crap, I got it wrong. Either way, it's C. All right, questions, comments, concerns on this problem? Know how to do these, they're easy. I put them on the test, it should be really, really quick. It shouldn't take you 20 minutes to do it. If it takes you 20 minutes to do it, you don't have time to do other problems. All right, questions on the homework?
I just realized that questions, comments, and concerns all start with the cuss sound. Please stop doing that. It's so weird.
And yes, Fatima.
47.
47?
Yes.
Okay.
Not a particular question.
Not a particular question, just I don't know what I'm doing type question. Okay. So you see how it's sine alpha, kind of, it's sine times cosine plus cosine times sine. Guys, can I be the only one that's talking right now? Thank you. So we have sine times cosine plus cosine times sine. So the problem is that we have that negative 87, and that is not a mistake. That negative 87 is not a mistake. So either we need to pull that negative sign out front, or it has to just kind of disappear. And since it's cosine of a negative, we can rewrite it as the cosine of the positive. So that's exactly what I did. I rewrote that negative 87 as a positive 87. Now we have sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So we can go all the way down to the fact that that equals sine of alpha plus beta, which equals sine of 90 degrees, which just equals 1 because it happens to be on our unit circle. So I can go a little further.
Okay.
Did I lose you at any point in that rambling action? No? Make sense?
I think so. Yeah.
Does it look too easy now? Too hard? Right in the middle?
It's okay.
It's okay. All right. It was just like our bell work, basically. It's our bell work of that if I see this, I can rewrite it as this. Other questions? Yeah? 58. 58 is a good, that's a doozer. Let's go through 58. All right, 58 is sine of 136. So you probably got the first step right. You probably said, hey, I'm using cofunction. So I can rewrite that as cosine of 90 degrees minus 136, which comes out to being cosine of negative 46 degrees. And you're like, I have my answer. I just got to go to the, oh no. It wasn't any of our answers. Oh, but wait a minute. Cosine of negative 46 is the same thing as cosine of 46 degrees. I got you, Mr. Pavian, because now let's go. That's not one of them either. Is that kind of where you got stuck around there? So let's push through and say, well, I know I'm using cofunctions. Let's use cofunctions again. So cosine of 46 degrees does equal sine of 90 degrees minus 46 degrees, which equals sine of 44 degrees. That one is one of our choices. I forget which it is. H. So our answer is H. So you had to kind of... So the weird thing about this, if I would have done the cofunction, if I did the sine of this, if I did the cofunction using the sine of this, I would have worked back to this angle. But because I can rewrite this as a positive, then rewriting it as sine comes up with a brand new sine of 44 degrees. But the cool thing is, this long chain is true. If I would type in sine of 136 and sine of 44, you come up with the exact same answer on your calculator. Yes?
I don't get how you can go from cosine 46 to sine 90 minus 46. Is that like...
Cofunction.
Yeah, okay, it's one of the...
Yep. It's the cosine of u equals the sine of pi over 2 minus u. We're in degrees, so I change the pi over 2 to 90, and my u's are 46. Yep, I just use the cofunction again. So you just put down C. One of them doesn't get used. Right. Gotcha. And then you quit. You just say, All right, other questions from the homework? Yes?
I have a question about tonight's homework.
What? Come again?
I have a question about tonight's homework.
Did I? Okay.
Is it like humongously spaced because
It's humongously spaced because A, we're going to do a lot of work in those spaces, and B, it's not as much work as I gave you space for. It's for people that write big
okay, so in
and are
reality,
disorganized.
how long do you think this will take?
In reality, it's the same amount as normal, and we should have time to work on it. Yeah, it's not any longer. And in fact, people are going to be very, very angry about this.
Oh, oh,
Oh,
okay. I can deal with that.
This homework used to be enormously long, and I did put a note on it. I didn't read it before I started planning everything, and I put on that the homework was way too long. So I split this homework up into, so it's actually smaller than it was, and tomorrow we'll have time to work on it. So our test won't be till next Wednesday. We do have a sports assembly, so our classes are going to be a little bit shorter, but that's okay. I just take off a question.
Oh,
I pace it. I don't... I'm not going to give you the same length.
teachers
And
do that though.
You guys will be fine. You guys will be fine. Remember, you come early, you hurry up from your other class. I let you stay an extra 2 minutes or 3 minutes after.
Oh, if we have like lunch after this, we can like.
Stay for a little bit, yeah.
Cool.
The only thing you can't do is leave and come back. Because then most of you I can trust, but there's always the one that's going to look it up. All right. So does that answer your question about the homework?
yeah, I'm just wondering because the French teacher last year when I met her would have like, do you remember like her essay questions? Like
Yeah.
massive spaces, you have to fill the entire thing, and it's.
All right. Anyway, so test is next Wednesday. If you really wanted to take it Tuesday, I can hand it to you Tuesday.
Yeah.
If you really want to.
So we'd have no homework too.
Wait.
But any other questions on the homework?
This isn't homework, but it's about...
The test is on Wednesday.
Yeah, but so now are we reviewing on Monday and Tuesday?
Correct.
Not Friday and Monday?
Not Friday and Monday. Correct.
Because weren't we doing that before?
Yes.
If we take the test Tuesday, what do we do Wednesday?
I don't care. All right. Anyway, any questions on the homework? Yes.
Why can't 58 be?
Why can't 58 be E? 58? Why can't it be E?
Yeah. That's what I got too. I got E.
Because it can't be E. The only way it could be E, let's bring this guy down here and rewrite it as cosine of negative x. The only way it would be E is if I could rewrite this as negative
Oh, wait, that is
cosine of x. Does that make sense?
Yeah.
It does make sense?
Because of Earth.
Oh, it makes sense why it's wrong, right?
Yeah.
Okay, yeah. Because this has to be cosine of x. The negative can't get pulled out. That's why it's on there, to make you think it's that. They're little scoundrels. Okay. Let's get to the homework so we actually have, or notes so we can actually have time to work. All right, the first time I'm going to walk you through, and then the second one I'm going to walk you through how I would organize it on the sheet, because obviously you don't want to have to write all of this out verbatim in a long order type fashion. All right, so I'll kind of do how I organize it on the sheet. But in short, we're finding the exact value of sine of an angle plus an angle, so alpha plus beta. And they're going to give me two things. Every one of these is going to give you two things. This one gives me that sine alpha equals negative 3/5, and it tells me that cosine beta equals negative 1/3. It also says where each of our angles is. So it says alpha is in quadrant 4. So if ever I'm dealing with alpha, quadrant 4 tells me all students take calculus, only calculus is positive. If I'm dealing with alpha. If I'm talking about beta, I'm in quadrant 3. All students take, only tangent will be positive, so sine and cosine will be negative. That's important to know. The first thing you're going to do is say sine of alpha plus beta equals sine of alpha times sine of beta plus cosine alpha sine beta. But you realize the two pieces of information we have, we can already insert those into that equation. Because sine alpha equals negative 3/5, so I just plug that in there. So I just take that 3/5 and plug it in for my sine alpha. And then I took my cosine alpha, which is negative 1/3, and plugged it in for my cosine beta. And I have a number here. I could actually simplify this to being a positive 3/15. The problem is, I don't know either one of these two. Yeah, did you have a question? Oh, okay. Oh, thanks. We'll simplify it down there. The only thing I'm missing is cosine alpha and sine beta. If I find those two numbers, I'm done because it's just simplifying after that. The hard part is just finding cosine alpha and sine beta. So I just put these two boxes down to find each of these. Let's take a second real quick to shortcut this. To find cosine or sine, we're going to go back to the fact that cosine squared, let's use alpha for this, cosine squared plus sine squared equals 1. The reason why I'm writing that up there is because if I manipulate this just a little bit, subtracting sine from both sides and taking the square root, we're going to see that cosine alpha actually equals the square root of 1 minus sine squared alpha. Knowing this, or coming up with this before you do any of these, can save you a bunch of space and pointless mistakes. Alright, so we're going to use that fact to solve for cosine and for sine. I'm going to bring up another slide just so it's a little higher, so it's there. Alright, so I'm finding cosine alpha. Well, cosine alpha is just going to equal the square root of 1 minus sine squared alpha. But we know sine of alpha is negative 3/5. So I can rewrite this as the square root of 1 minus negative 3/5 squared. Please tell me if my numbers are off because I can't actually see any of the values up there. I'm just kind of remembering. We just got to simplify this. That's going to equal, and what I always do with these, do you see that the denominator is going to be 25? Because it's going to be 5 squared. Do we all see that? I'm just going to turn my 1 into 25 over 25 just to save me an extra step. So I'll write 25 over 25 minus negative 3 squared is 9 over 25. No, negative 3 times a negative 3 is a positive. There is still a negative out there, right? But these are always going to be positive. It's a good thing to remember. These are always going to be positive, so even if we forget to put the negative sign here, it's going to be positive. But we have 25 minus 9, which equals the square root of 16 over 25, which equals 4 over 5. That might not be 100% correct because it's either positive or it's negative. Yeah. Because it's alpha, and alpha is in which quadrant? 4, so it's going to be Positive. Yep. Since I'm in quadrant 4, it's going to be positive. Remember, this is quadrant 4. Yes.
So, I don't have a question about how we did this next week, but it's like a essentially different thing. So, well, it's a, I mean,
Okay, just go forward with the question.
If the sine of alpha is negative 3/5, couldn't you find like the sine inverse and you just get alpha? Or no?
No.
Okay.
Well, you could find alpha. Yeah, so you could. So if you know that sine alpha equals some number, you could take the inverse of both sides, get your alpha, and then plug it in for cosine. So that is another way you could possibly do it.
Okay.
Yep. Solving for sine beta. So I'm just going to skip to sine beta equals the square root of 1 minus cosine squared beta. So that means sine beta equals the square root of 1 minus a negative 1/3 squared. But that's just going to equal, once again I look at the denominator, is going to be 9. So I'm going to change my 1 to 9 over 9 minus 1 over 9, which equals the square root of 8 over 9. Which is equal, so we're going to have the square root of 8 over the square root of 9. Square root of 9 is easy, it's just 3. Square root of 8 is actually simplifiable because 4 goes into it. So you could rewrite the square root of 8 as the square root of 4 times 2, so it's going to be 2 square root of 2. Yeah, thank you. It's going to be 2 square root of 2 over 3. I got to know if it's positive or negative, guys. What is it? What is it?
Negative.
It is negative. It is negative because we are in quadrant what? 3. I do want to go back to that statement of inverses real quick. Why you can't do that is because this would be a problem that says you can't use your calculator on or something, okay? And you can't do inverses in your head. Well, maybe. None of us can, probably. No. Then you can. Okay. I have my bits of information. I have 4/5 is my cosine alpha, so we're just going to plug it in for cosine alpha. I got that is my sine beta, so we're just going to plug everything in. Yeah.
So is it negative because in quadrant 3, the whatever they are?
All students take only tangents positive.
Okay.
So sine has to be negative. All students take, right? All right, so we're just going to write all of our information down from above. So I have negative 3 over 5 times negative 1/3. And then we're going to have plus whatever our cosine value was. So we have 4 over 5 times whatever we got for our sine, which is an awesome negative 2 square root of 2 over 3. Whew. Simplify, simplify, simplify. Negative 3 times a negative 1 is a positive 3 over 15 plus we're going to have 4 minus that 2 square root of 2. You quit it. So we're going to have 4 times that negative 2 square root of 2, so we have negative 8 square root of 2, all over 15. And then we're going to push those guys together to 3 minus 8 square root of 2 over 15. Almost all of these, in fact, I can't think of one offhand that doesn't. Your denominators will almost always be the same. I can't think of one case that it wouldn't be. So we'll just stick with it. Your denominator should always be the same. So you can push it together right away. All right, that kind of is a good checkpoint. Are my denominators the same? Then I did everything correct. Is it a ton of work? I don't think so. It might be a little bit more than we're used to. But it really is just stay organized. Every bit we've done before. There is nothing in here that's brand new. There's nothing in here that's brand new that we haven't done before. It's just putting some things together. Questions, comments, concerns on that problem? All right, on the next one, I'm going to show you how I'm a kind of a disorganized guy, and if I didn't have any organization, I'd kind of slap a whole bunch of information down and hopefully piece it together at the end. So to keep these organized for me, and you'll see it on my answer key. I do this every single time as well. I stop reading here. I stop reading here, and I write down what the formula is for this. So it says find the exact value of cosine alpha minus beta. So I'm going to stop there, and I'm going to say what that means to me. What that means to me is cosine alpha minus beta equals, well, that's going to be cosine alpha times cosine beta. Minus becomes plus with cosine. And then we're going to have sine alpha sine beta. Because now I know all the values I need. I need all 4 of those. Now I start reading, and it says my sine alpha is 1/3. So my sine alpha is 1/3. My cosine beta is negative 1/3. So I'm going to start filling in the information that I know. All right. I do not know my cosine alpha, but I know my cosine beta. My cosine beta is negative 1/3. Plus, I know my sine alpha. My sine alpha is going to be 1/3. I'm going to make that a little bigger. I have space. So my cosine beta is negative 1/3 plus this is 1/3. I do not know my cosine alpha. I do not know my sine beta. So those are mysteries. That tells you you need to find those two.
Tells you to give up.
It tells you not to give up. It tells you to continue. Notice both of our ables. Both of our ables are in quadrant 2. Both of our ables. Angles. Yeah, that should say angles. It should say angles. Don't worry, it's corrected now. The next class will have angles for there.
Like next year.
Yeah, not you guys. Won't help you out at all. Unless you're printing it off at home, because then I'll save it as the correct one. Both angles terminate in quadrant 2, so both of them are quadrant 2. All students, sine is positive, cosine is negative. All right, let's go ahead and find our cosine alpha first. So what I do now is I just put a little wall up. Boom, 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 boom. We're doing some side work here. I'm looking for cosine alpha. So cosine alpha is going to equal the square root of 1 minus sine squared alpha. We actually know what sine alpha equals, so it's 1 minus 1/3 squared. That 3 squared in the denominator is going to be 9, so I'm going to change that 1 to a 9/9 minus 1. Okay, it's square root of 9/9 minus 1/9, which is going to equal square root of 8/9. But just like we had above, that's going to be 2 square root of 2/3. We are in quadrant 2. All students, sine is positive, cosine is negative. So that right there is my cosine alpha. So I'm going to go ahead and plug that in right there. Should probably left myself just a little bit more room. So we have negative 2 square root of 2/3. And the last thing I have to get is sine beta. But that ain't no trouble, because sine of beta just equals square root of 1 minus cosine squared beta. Cosine beta is negative 1/3. Let's go 1 minus the negative 1/3 squared. We're going to see, do you kind of see how this is going to be the exact same answer? Except it's going to be positive. Because if I follow this down, we're going to have the square root of 9/9 minus, since it's negative 1/3 times a negative 1/3, it becomes a positive 1/9. So we have 9/9 minus 1/9. We already did all this work on the other side, so we don't need to do it again. It's just going to equal 2 square root of 2/3, but this time it's positive because it's sine. And we throw that next to here, so we have a positive 2 square root of 2/3. So now I have all of my parts. Multiply, simplify, and you have your answer. So we have negative 2 square root of 2 times 1. So we're going to have equals a negative 2 square root of 2 over 3 times 3, which is 9er, plus 1 times 2 square root of 2 is 2. It should be positive. Whew, slow down, Mr. Pagan. Because I have a negative times a negative gives me a positive 2 square root of 2. The other side is going to be 2 square root of 2 as well, over 9, which is going to equal 4 square root of 2 over 9. I can't think of a problem also. So what made me stop there is I would have had negative 2 square root of 2 plus 2 square root of 2, which would have turned to 0. I can't think of any of these that actually equals 0. All right, so if your numerator turns out to be 0, retrace your steps. If you think everything's fine, just leave it. But more than likely, you made a mistake somewhere, just like I did. Because I would have came up with 0 if I would have continued on with that being negative 2 square root of 2. Questions, comments, concerns? So this is about as much work as you need to do. All right, is that a ton? No. And in fact, a lot of this stuff you can kind of skip in your head, right? If I know what this is, you might be able to skip to here and there. It really isn't that much work. All right, verifying identities, we're going to be going back to this. The cool thing about these is we know how to do most of it. The only thing we might be missing out on is we haven't done this, is rewriting this. All right, so if I have cosine of x minus pi over 2, and I'm trying to verify this, remember we build a wall. We build a wall between the two. I'm going to do that secondary. I want to make sure how much room I have. I'm just going to rewrite that cosine of x minus pi over 2. And I'm going to rewrite that as, cosine of x times cosine of pi over 2. Since that's a minus, it becomes a plus for cosine. And we have sine of x, sine of pi over 2. Now I'll build my wall once I know what my initial thing kind of is. Here's the cool thing about these. Unit circle. I have cosine of pi over 2. I have sine of pi over 2. If you look at your unit circle, or you remember, pi over 2 is a key point. It is the point 0, 1. So cosine, in fact, is going to equal 0. And sine is going to equal 1. So up here, we're going to have cosine of x times 0. This just becomes 0. Plus sine of x. And sine of pi over 2 becomes 1. So cosine of x times 0 that's donezo. I just have sine of x. Well, it seems like a good stopping point on that side. I can't really simplify that any further, so we just go to the other side and say, well, cosine of x times I can rewrite tangent. So I can rewrite this side as cosine of x times tangent becomes sine of x over cosine of x. My cosines will cancel out. I'm just left with sine of x equals sine of x. Tonight you're going to have 2 of the problems like this. Tomorrow we're going to have much more complicated ones. All right, that take a lot of steps. All right. Good otherwise? All right, let's go ahead and do the homework. The solutions have already been